All right, let's dive into a truly mind-bending idea, one that could completely flip our understanding of the universe on its head. It's called the entropic force field hypothesis. And wow, it tackles some of the biggest, thorniest puzzles in physics, starting with a problem that really bothered one of the greatest minds who ever lived. You've probably heard this famous quote. It perfectly captures why Einstein was so uncomfortable with quantum mechanics. You see, he was a firm believer in a universe of cause and effect, a place where everything made sense. So the apparent randomness of the quantum world, it just felt wrong to him, incomplete. He was convinced there had to be an underlying rulebook that we just hadn't found yet. And that's exactly the question this new hypothesis dares to ask. What if all that randomness we think we see at the quantum level, what if it's just an illusion? What if the universe isn't rolling dice, but is actually playing a game of cosmic chess with a very specific, unbreakable set of rules? Now, to understand how this could even be possible, we need to totally rethink a concept we usually link with chaos and things falling apart: entropy. This hypothesis reimagines it completely. This right here represents a massive shift in thinking. Normally, we're taught that entropy is just this passive trend, the universe slowly getting more and more disordered. But this hypothesis says something totally radical. What if entropy isn't passive at all? What if it's an active, powerful guiding force that's actually orchestrating events at the quantum level? And that brings us to the core idea, an entropic force field. Think of it like an invisible, behind-the-scenes director for the entire quantum show. It's not about chance. This field literally shapes the behavior of particles, guiding them down specific paths that are all determined by the laws of entropy. So in this model, the universe isn't random, not at all. It's following this incredibly structured, deterministic script. And you know what? This aligns perfectly with Einstein's gut feeling of a cosmos that makes sense, replacing the scary unpredictability of quantum dice with a clear guiding hand of entropy. Okay, so now let's see how this incredible idea can be used to solve one of the absolute weirdest phenomena in all of physics, what Einstein famously called spooky action at a distance. The problem is something called quantum entanglement. It's wild. When you link two particles, measuring one instantly affects the other one, no matter how far apart they are, even if they're on opposite sides of the galaxy. To Einstein, this looked like they were communicating faster than light, which his own theory of relativity said was impossible. It was a paradox he just could not accept. To make this easier to grasp, let's use a simple analogy. Imagine you have a pair of gloves. You put one in a box and send it way, way out into space. The second you open your box and see you have the left glove, you know instantly that the other box contains the right glove. No spooky message traveled between them. They were always a connected pair. And this is basically how the hypothesis offers a solution. The entropic force field acts like an invisible thread connecting these entangled particles. They aren't communicating instantly, no. Instead, they are both being influenced by this one overarching field, which makes sure their properties stay perfectly linked. That spooky action is suddenly just a deterministic effect, totally in sync with the laws of physics. Problem solved. This idea also changes the whole game for the observer. You know how in quantum mechanics, the very act of looking at a particle seems to force it to pick one reality out of many possibilities? It's called wave function collapse. Well, instead of a person causing this, the hypothesis suggests the entropic force field itself drives the collapse. This would mean there's an objective reality out there that exists whether we're looking or not, another thing Einstein always believed. But believe it or not, the implications get even bigger. This isn't just about solving a few quantum puzzles. This hypothesis is aiming for the holy grail of modern physics, a single, unified theory that explains, well, everything. Right now in physics, we have these four fundamental forces. But each one is described by different and sometimes clashing theories. It's like having separate rulebooks for different parts of the universe, and they don't always agree. Physicists have been dreaming of uniting them for decades. And this is where the idea becomes just beautiful. Think of the universe as this grand cosmic tapestry. The four forces we see are like different colored threads, each one unique. This hypothesis suggests that the entropic force field is the underlying structure, the loom itself, that's weaving all these threads together into one single, unified fabric of reality. So this brings us to the final part of our journey, where the hard science starts to blend into some of the biggest, most profound philosophical questions we can possibly ask. I mean, think about it. Why does time only seem to move in one direction? Why do we remember the past, but not the future? Well, this hypothesis suggests a deep connection. Maybe our perception of time moving forward, what we call the arrow of time, is simply our experience of the universe following its guided path toward greater entropy. Time itself might be a consequence of this fundamental force. This also totally reframes how we might think about the end of everything. The old heat-death theory predicts a cold, empty, lifeless universe. But if entropy is an active, organizing force, maybe the end isn't so final. It actually raises the mind-blowing possibility that even from the ashes of a dying universe, new structures, new forms of order could rise again, all driven by the very same force.
So what does this all mean for us? For you and me? If the universe really is deterministic, guided by this invisible force, it completely changes our place in it. We're not just random accidents in a chaotic cosmos. We are, in a very real sense, part of this grand entropic dance, deeply connected to everything and everyone around us. We're all participants in a story that's unfolding according to a fundamental cosmic law.
And that leaves us with a truly humbling and yet awe-inspiring final thought. This perspective suggests we're not just watching the universe from the sidelines. We are an essential part of its unfolding story. It speaks to a deep interconnectedness of all things and reminds us that our quest for knowledge is always ongoing, revealing a universe that might just be far more intricate and maybe even more purposeful than we ever dared to imagine.